Okay, well, we're going to kick things off and talk about some science now. I'm going to give an overview of the center, for those of you who maybe aren't familiar with what we do. So what is the Center for Clean Water Technology? Well, firstly, let me tell you our mission, which is to harness science to engineer clean water solutions for the protection of public health and the environment while promoting economic development in New York and beyond. And if you wanted to go on campus and you held up a map to find the Center for Clean Water Technology, you wouldn't find it. And that's because, in my mind, we have taken the best resources of the entire university that are focused on water and brought them together in what we'd call a virtual center. We certainly have labs all across the university. But we bring people together from SOMAS, from the chemistry department, chemical engineering, civil engineering, even the medical school, all focused on solving water quality problems. And we have four main thrusts of what we're doing research on. You're going to hear today about our work on removing nitrogen from wastewater, removing phosphorus from wastewater, removing emerging contaminants, specifically PFAS, from drinking water. And then we also do a lot of work on something called wastewater-based epidemiology, which is trying to understand community, it's a community surveillance tool for protecting public health and understanding public health trends. Across the university, we've got more than 30 scientists, faculty, research scientists, PhD, postdocs, graduate students, et cetera. And we're supported largely by the state, and we're very thankful for that state support from the DEC and from the Department of Health as well. But we also get our own funding external from the state, getting support from the counties, from philanthropic sources, from federal grants as well. And you've heard the theme of the day already, our partnerships. And again, we're largely state supported, but we get a lot of support from Suffolk County. We also, in the wastewater-based epidemiology space, are working very closely with Nassau County. And we work with many of the towns in Suffolk County as well. And I'm just highlighting three, but we've worked with lots of different municipalities, villages, et cetera. And obviously, we're focused on water. But if you look nationally, there are, water centers aren't unique. There's many of water centers across the United States. There are water centers across the world. But our focus is somewhat unique in that we're focused on water quality, and we're focused on how that water quality can be affected as water travels through a watershed, through an aquifer, and how that, in turn, may even affect surface waters. And one of the big issues that we're dealing with, of course, is nitrogen and the over-enrichment of nitrogen in our groundwater. As the population of Suffolk County grew through the 20th century and we transformed from a rural county into a highly suburban county, the concentration of nitrogen below our feet in our drinking water source continually increased. And put us to a point where we have some of the highest levels of nitrogen in our groundwater, our drinking water, compared to the rest of the country. That's just showing here that there's over 200 million people in the United States who have drinking water with less than 1 milligram per liter of nitrogen. And if you look across Suffolk County, there's certainly areas that are below the average, but there are other areas that are really concerning that are well above. And that heavy nitrogen loading that's going from groundwater into surface waters have implications for water quality on many fronts. And this is a map that my lab had put together from last year, showing in 2025 the vast array. Let's see how this pointer works. Oh, there we go. The vast array of harmful algal blooms and low oxygen zones that you can find all the way from way out towards Montauk all the way in to the western extent of Long Island. And in many cases, these are being promoted by excessive nitrogen. And that what you could call the trail of tears that have been left behind by excessive nitrogen loading is substantial across Long Island and specifically here in Suffolk County. You look at some of our top fisheries. I mean, there was a time where the top fishery in New York was the hard clam, right? Landings down by 99%. There was a time where people got more bay scallops out of the Peconic Estuary than any other estuarine system in the country, and that down 99%. Ed talked about going in the water way back when he was a boy, and he could see to the bottom. in that same water body, he was surrounded in many places by seagrass. And in Great South Bay now, there's very little seagrass left. And that has very important implications for coastal habitats. And then finally, salt marshes are a critical habitat, and we've lost many of those. And in all cases, for all these different losses, you can make direct and indirect links to the role of excessive nitrogen loading. And, we know where that nitrogen load is coming from. Decades ago, people would say, oh, it must be the runoff. And then maybe 15 years ago, people would say, oh, well, it could be fertilizer. But, the studies are in, the studies have been done, and we know that, as I had alluded to, with 70% of the county unsewered, the biggest source of nitrogen from land to sea is on-site septic systems. And again, it has ecological impacts. And so we're ultra focused on how do we deal with these old antiquated systems that are literally just discharging right into our drinking water source. How do we modify that? How do we make that better? And you'll hear about that today. Another thing you're going to hear about today is phosphorus. And in fresh water, there are a specific type of harmful algal bloom called cyanobacterial blooms. You're looking at one here. This is Lake Agawam in the town of Southampton. Anyone want to go for a swim? But there's a running debate actually amongst scientists. What's important? Is it nitrogen? Is it phosphorus? And it turns out that in freshwater systems, phosphorus ends up being very, very important. And in many places, on-site septic systems can be a key source of phosphorus that, again, just like nitrogen, can load into groundwater and then stimulate these harmful cyanobacterial blooms. And this is a serious issue in New York State. You can see they're widespread. Those little dots are places where they've seen these blooms. And gets very serious outside of Long Island. We are the New York State Center for Clean Water Technology. As you'll hear today, we are even working with upstate communities and counties. And in places like Skinny Atlas Lake, that was such a pristine lake that it's the water supply for the city of Syracuse. It was one of the, I think, only a handful of lakes where they didn't have to do anything to treat the water, right? So it's just pristine water, and obviously things have changed over time. So we're also, you'll hear today what we're doing towards developing technology to get phosphorus out of wastewater and other forms of water as well. And then the final thing you're going to hear about today are emerging contaminants, and we heard about this is a pressing issue here on Long Island, but across the country. And again, we have this grand experiment where our wastewater is going to our drinking water source, and it's a dangerous gamble. When we first started the center, the first compound we worked on was something called 1,4-dioxane, very serious compound, a carcinogen, and actually the highest levels ever measured in a drinking water source were here on Long Island, specifically the Hicksville Water District. And so one of the first things we did as a center was to work on that specific issue. But another issue that we've been working on more recently is these forever chemicals. They're very, very serious PFAS chemicals. And the reason they're so problematic is that these were synthetically synthesized in the mid-20th century as a great breakthrough for household products because the carbon-fluorine bond is so strong, very, very difficult to break. And so that the scientists were very excited about that. And it had all sorts of positive properties for different things like non-stick pans and other things, firefighting foams. But of course, now we come to realize this is a carcinogen and potentially very, very dangerous. And I just pull out this data from the USGS, specifically with regards to PFAS in drinking water. Right, so this is a survey of the upper glacial aquifer they do. They have these what they call sentinel sites that are just regular, and then sites that are downstream of wastewater treatment fields. And so if you look at the scattergram here, it's a log plot on there's different compounds, as you can see on the y-axis there. There's the different PFAS compounds. I highlighted the two that are regulated by US EPA currently. And what I'm showing you is what the original standard was for New York State. Well, that standard's now dropped, and there's a new EPA standard on this front as well. And so what you see when you look at these numbers is that there's almost virtually no sample amongst all of these that meet that new standard. So we clearly need technological advances in order to address this issue. And you'll hear later today the very multifaceted issue that we're taking towards both removing the PFAS compounds out of water, but then also destroying those compounds. So essentially making those forever chemicals no longer forever. I'm pleased to say just last Friday, a week ago today, we had U.S. EPA Administrator Lee Zeldin here visiting the Center for Clean Water Technology. He specifically, we didn't know he'd be coming, but he specifically heard about the work that we're doing on PFAS and destroying and removing PFAS and wanted to learn more about it. So we were honored to have him here. We gave him a presentation on the research that we're doing, and then he went into the labs because he wanted to see the technology. And frankly, he was on a tour of all New York State, talking to different places about PFAS and how to get PFAS out of water. But we were honored to be one of the 2 spots he stopped at on Long Island. And as I wrap up here, I just want to highlight some of our major accomplishments. We've been around for about a decade as a center. We have more than 80 publications in international peer-reviewed journals. If we were a professor, we'd qualify for being a full professor in just 10 years, so that's pretty good. We've secured millions of dollars in external funding outside of our state support from federal sources, local sources, philanthropic sources that have really allowed us to push the needle and advance everything that we're doing on all fronts. I mentioned 1,4-dioxane. I'm happy to say that the first work we did, we were commissioned by the state to help address 1,4-dioxane. And in that work, we're able to identify the technologies that work the best for removing 1,4-dioxane, but also making sure we weren't creating byproducts that could be a further problem. And those technologies are now being implemented at all the places where there are high levels of 1,4-dioxane in drinking water. You'll hear today about our NRB septic systems we developed that have achieved some of the highest nitrogen removal and emerging contaminant removal in Suffolk County. You'll also hear about a new system we've developed fairly recently that may end up being one of the most cost-effective innovative and alternative septic systems available in Suffolk County. We also have multiple technologies you hear about today for removing phosphorus, where we can remove more than 99% of phosphorus out of wastewater. It's hard to do much better than that. And then again, you'll hear about all the work we're doing on PFAS to both remove PFAS and also destroy those forever chemicals. And our name is the Center for Clean Water Technology. So I'm proud to say that since our founding, and actually most of this has come just in the last 5 years or so, we have 7 different either patents that we've secured, or patents that are provisional, or patents that are pending, and on multiple fronts: on the nitrogen front, the phosphorus front, on the PFAS front. So not only are we doing the research, but this is research and discoveries that have never been made before. And therefore, that's what you have to achieve, obviously, to be patented technology. So I'm very proud to be directing the center, and particularly proud of these advances. Thank you.